SimpliPhi Power was originally founded back in 2010, which is kind of a long time ago in the whole lithium-ion battery world. At that time, a lot of the companies coming to market were bringing cobalt-based chemistries. We were one of the very first companies to bring to market a lithium iron phosphate chemistry, and that is inherently more safer lithium-ion battery chemistry. Originally, we were called OES Energy, and we used these batteries in the film and broadcast industry, so kind of high demand, high movement, portable systems. 2011, 2012, we had a great opportunity to work with the military. Originally, the military didn't want to use lithium-ion batteries, but they needed to do something. They were using a lot of diesel to run generators. They were using lead-acid batteries that just weren't living up to their needs. So we approached them. They said, we approached them with a safer chemistry. They agreed to test it. They did out at the Aberdeen Proving Grounds out at the East Coast. And they eventually liked what they saw and decided to deploy with our products. And so that was a really big win for them. It was a really big win for us. 2013, 2014, we began to expand our product line. And that's when we introduced our standard Phi battery. And this has really been one of our bread and butter products ever since then. We're going to talk about it here, but it makes a great drop-in lead acid replacement or even in other applications. We expanded to some of these portable systems you see there. 2015, 2016, we relaunched as SimpliPhi Power. And that's when we started to introduce our fully integrated energy storage systems like our Access system you see there. We also continued to work with the military, this time the Marine Corps. 2017, 2020, we've been just ramping up production. We moved into a new headquarters and we opened up a research and development facility. We actually assemble these batteries in Southern California, in Oxnard, in Ventura County. So that's something I'm really proud to say. And also more recently, we've released our Amplify battery, which we're going to talk a lot about during this presentation because that's the one that has the digital battery management system that has communication capabilities. I've been using this slide for so long. One thing I need to add on to it is another section where we have now merged with Briggs & Stratton, and we're releasing some new products, a new fully integrated energy storage system that I'll talk about a little bit later on in this presentation. So originally, we were founded as a safer alternative to some of the other batteries on the market. And really, you don't have to believe my word for it that we're safer because we've gone to the UL. We've got UL 1642 listing on our cell levels, which are the cells inside of a battery module, 1973 UL listing on the battery modules, and 9540 on the system level. We've also done the 9540A testing protocol, which is essentially they take one of our energy storage systems, put it into a test chamber, them being Underwriters Laboratory, and they wrap some of our battery cells in heating wraps and force the batteries into thermal runaway, and then they watch what happens. Well, not a lot happened, really, and I'm kind of happy to say that yes, they got a cell inside a battery to go into thermal runaway. It spread to some of the adjacent cells, but it didn't propagate beyond that. It didn't propagate internally in that battery to other batteries outside the cabinet into this test chamber, which you could imagine would be your garage. So it's a really nice thing to have these listings. If you ever are looking to purchase energy storage systems, you should always be looking for these listings, not just for peace of mind, but a lot of authority having jurisdictions, a lot of code inspectors are going to be looking for these, asking for these. The last thing you want to be is that you're trying to pass inspection. It's the last day, the homeowner's looming over you, wondering if you're going to pass, and the inspector starts asking for UL listings. Of course, you want to check ahead of time to make sure you're not in that area, but we're covered with our products. If you're off grid, you don't expect an inspector to ever come out. You're still going to want to look for those UL listings, because if you ever sell the property or you ever have some sort of insurance claim where you have to have an insurance adjuster out there. Almost through the beginning stuff, but this is an important slide. I want to talk about chemistry, right? I already mentioned that lithium iron phosphate is our chemistry we use. And not to say that cobalt-based chemistries don't have a time and a place, right? Cobalt is a very energy dense chemistry, so that's why we see it used in our phones, in our laptops, in our cars. But when we're talking about home storage, stationary storage, we're not as concerned about weight. What we're most concerned about is safety. So we're using that safer chemistry, but what makes our batteries safe is more than just the chemistry. It's also the form factor, the battery management systems that we've been using, the intellectual property that goes into these, the design of the battery, how we put things where. Inside our batteries, we use a cylindrical form factor. So think, AA, think AAA batteries. They're in a metal case, which contains any sort of thermal runaway a lot better than, say, a pouch cell, which is just foil wrapped. The cylindrical cell has the negative and positive on either end, so it's really hard to short out, and it gives us that performance. Pouch cells, like I said, have very little protection. They're prone to puncture. They can swell. Prismatic cells, they work great. There's nothing too wrong with them. They tend to be a little bulky for what we were looking to make. So the combination of the chemistry, the form factor, and our battery management system is really what's given us this safe product. So let's get into it. We're all here to hear about battery management systems, so let's start talking about it. When we're bringing these lithium-ion battery chemistries to market, we need battery management systems. We need them to keep the battery from going outside of its safe operating parameters. We need to protect lithium-ion batteries when they get to extreme temperature environments, to either hot or cold environments. We need to be able to calculate some of the internal data in the battery. Some of them can do that. They can actually transmit its state of charge, its current flow in and out. And it also really needs to be able to keep the cells balanced within the battery. So ultimately, battery management system is to protect the battery from damage and ensure the battery can access its full capacity. So if we have a lead acid battery, right, the good old lead acid batteries, if you were to overcharge this, either with too much current or to get it too high of a voltage, you're going to break the battery, but you're not going to send this thing into some sort of catastrophic thermal runaway event. So if we're talking about cobalt NMC based batteries, we absolutely need a battery management system to open a contactor, open up some sort of circuit so that it doesn't allow that battery to continue to receive that too high of flow of charge or too high of a voltage. You probably could add a battery management system to a lead acid battery, but really a lead acid battery, it inherently in and of itself can keep its cells balanced. It has a much wider voltage range, so it can handle a little bit more abuse. It would probably benefit performance-wise, but the cost, it really comes down to the cost of how much does that battery management system cost to put in, and does it justify the shorter life of a lead acid batteries? And usually the answer is no. This is an example. Now, this isn't our internal battery. Again, these first couple of slides, I'm just talking in generals in a battery management system. But what we're looking at here is a 12-volt system, and we have a battery management system, and you can see that the battery management system is running through the negative side of this battery. Some battery management systems have temperature sensors, some don't, right? So in some of them, they might have a 10K thermistor, and as the battery gets too cold, if it has a digital battery management system that's able to transmit data to pieces of equipment like an inverter, it can tell that piece of equipment, hey, I'm starting to get cold, or I'm starting to get too cold, I'm below freezing, and stop the charge because you're going to damage me. And what's great about having that 10K thermistor is it inside of the battery cells itself. So it's getting a very accurate reading of it's not reading ambient temperature in the battery compartment or outside. It's actually in the cell. Battery management system is going to open and close when it wants to protect itself. It's using either contactors or FETs to do this. But it's important to understand that a battery management system isn't going to alter or change current or voltage flowing into it. It's really there as a lifeguard to protect the battery from damage. So a battery management system is not an excuse for a poorly programmed system or a poorly sized system. And we'll talk about sizing here in a minute. So to start with, analog battery management systems, they're the most simple, the least expensive. These analog battery management systems are programmed during the manufacturing process, and it's just a flash program, right? So you're not able to adjust the programming or change it. It's just made up of hardware like FETs, resistors, and diodes. And the way it operates is based on electrical signals, not communication between pieces of equipment and the battery management system. So the analog battery management system is just looking at values across components, like voltage, like current flow. And if it doesn't like what it sees, it's going to either open or close a switch to protect itself. Once it sees conditions return to a nominal state, it can go ahead and reconnect and allow power to flow in and out of the battery again. This isn't actually our analog battery management system either. This is just an example again. So the analog battery management system is not transmitting data to other pieces of equipment. It's not pre-populating set points. It's not telling pieces of equipment what its state of charge is. What you need is a digital battery management system to do that. And so a digital battery management system is going to be able to be programmed and have its programming changed in the field. It may or may not transmit a lot of data to external pieces of equipment. A lot of the ones I've seen do. So what is it transmitting? It's transmitting its state of charge. A lot of pieces of equipment that try to determine the state of charge of a lithium-ion battery based on solely voltage don't get it right. If we were to look at a chart of a lithium-ion battery, whereas one axis would be voltage and one axis would be state of charge, it's a very flat curve, which means that you could have a very large change in voltage, but yet have a very small change in its state of charge until you get to the either end of the curve. So pieces of equipment that are solely reading the voltage to determine state of charge have a hard time. Well, if we can measure amps in, amps out through a shunt, and we can transmit that data to the piece of equipment, we're getting a much more accurate reading. Also, we can read the voltage at the battery cell level and transmit that data. We're able to get a higher level reading. Some digital battery management systems have an analog battery management system as a backup. To take a step back a little bit, our Phi batteries, our SimpliPhi batteries, the 3.8s, those standards, those are considered low voltage battery management system or batteries, and we always want to run those in parallel. If you start to run those in series, you can start to run into some issues where the battery management system isn't capable of handling that high voltage it may see in a series configuration, right? So if you have, let's say, a bunch of 48-volt batteries in series, and you're stacking that voltage up, and one of those batteries is full, and it wants to decides that it wants to open circuit, well, now one of the batteries in that opens is now seeing that full stack voltage, and if that battery management system isn't rated for that higher voltage, maybe a lot of them are, it can fry that battery management system. So it's always important to understand that we want to do these in parallel, and that's how we're going to get a battery management system that's going to protect it. Now, in high voltage situations, when you have a bunch of batteries stacked and you have a stack controller on the top of that, that's been designed to work with that high voltage, and it can handle that full stack voltage. Each individual battery isn't going to have an internal battery management system. You're going to have one for the entire rack. And I have a picture of that later in the presentation where we can take a closer look at that. So it's different hardware between the high voltage and the low voltage. Again, Q&A chat's there if anybody's got questions as we go along. I talked about this earlier, right? The main reason to have a battery management system is so you don't set a lithium-ion battery on fire by not programming it right, and you get some crazy, and NMC batteries absolutely need this to protect themselves. So do LFP batteries. Another function is to keep the cells balanced inside the battery module itself. A couple different ways to balance cells is that at the bottom and top of each charge, we can do what's known as passive cell balancing. So here's our picture and our diagram over here, and you can see this battery here is full, and each of these other batteries aren't full. And we have a charging source that's flowing through, and it's going to charge this battery, but the battery management system has determined that this cell is full, and it's closed this circuit here so that now instead of power flowing into this battery, it's going to flow past the battery into this resistor, generate a little heat, and then keep flowing until all the batteries are fully charged. We're talking a small amount of heat. We're talking less than a 1/10 of an amp here. We don't want to be heating up the battery. And so, again, this is one method, passive cell balancing. Another method that is incorporated in these lithium-ion battery management systems is active cell balancing. Similar concept. What we want to try and do is get all the cells in the battery to the same voltage topped off, so that you don't have one cell in the battery limiting the capacity of the battery. Excuse me. Active is a little different. Before, we were kind of dissipating it as heat and rerouting it. In active, you can see we got a couple empty cells here, and we got a full battery with the and this is simplified. This isn't it's a little more complicated in real life, but essentially what happens is the full battery charges up a capacitor. The capacitor then can move or switch its leads to other cells that aren't as full and discharge into those other cells. Excuse me. So this is, again, at the top or the bottom of the charge cycle. If anyone here, and maybe put it into the comments, if anyone's building these batteries, putting them together, and you're using second life cells, which need this active cell balancing probably to function properly, this is a great way to do that. You can still have a passive cell balancing system in these batteries that incorporate both. And the passive balancing is usually a little bit larger in current, but still very small compared to what we're charging it, right? A Phi amplify or a Phi 3.8, we're charging those at 35 amps. And here we're talking about less than an amp as we're doing these active cell balancings. So just to kind of review a little bit, battery management systems are not an excuse for properly programming your system, right? Get into that, use our integration guides that we have on our websites, get into that Schneider, get into that Solar, get into that Magnum, whatever you got, and make sure you got your program set points, the most important ones set. And we'll talk about which ones are the most important here in a minute. A lot of digital battery management systems can, if they're capable of talking to some pieces of equipment, they can auto-populate some of those auto set points. but it's the battery management system still not going to modify any current or voltages coming in and out of it. It's just simply going to ask that external equipment to do the changes that it's looking for to protect itself. It works, with and independently from other equipment, and it can, more importantly, collect and report data, which is great for troubleshooting. When you call us up, we can look at and pull historical data. Analog battery management system, it's absolutely crucial that we get the correct programming set into those other pieces of equipment, because they're working independently of each other. And again, it's really to be the last line of defense. So imagine you got a Schneider system, you got your contacts panel right here. We got to get in there and set some of those set points. What are the major set points I want to see you guys, everyone using? Low battery cutoff. We don't want to discharge a 48 volt battery. Our 48 volt battery is below 48. That's as low as you want to go. Want to adjust that charge voltage, and more importantly, the charge current. All of our batteries have a C/2 rating. So a great example is if you got an 8,000 watt Radian with using the standard Phi batteries, which have the analog battery management system, we want to see at least 16 kilowatt hours of storage, so that never will that Radian pull or push more than what the batteries can handle for their max or for their continuous discharge or charge cycle. We're going to talk about SimpliPhi batteries. We let you kind of break that rule a little bit, because we know that the SimpliPhi batteries are going to be able to tell that piece of equipment, like, there's only 2 of us here, there's only 3 batteries here, don't exceed our continuous charge or discharge rate. There, again, to reiterate, the digital ones can auto-populate set points. The SimpliPhi batteries are going to automatically detect how many batteries are in the system, because we have little comm cables going between them. And then finally, this yellow one is the home run to the piece of equipment. And just, these are, if no one's seen these before, these are our bus bars here. It can transmit that data, auto-populate the set points based on its battery bank size. Again, what I should mention, though, is it's only our SimpliPhi batteries are only compatible with pieces of equipment that are able to talk to it. So currently, right now, that Solarc, right, the Solarc 5K, 8K, 12K, SMA Sunny Island, and our new SimpliPhi Briggs and Stratton inverter is able to communicate. So if you have these other pieces of equipment, like other inverters that have comms capable that we're not working with currently, we're always trying to expand to other pieces of equipment to bring that capability there. But you might benefit from just using the standard Phi batteries, programming the system properly, and save some money, because you're not going to be able to use the digital battery management systems in those other pieces. So up until now, I've been kind of talking about in generals. Now I'll kind of focus on our products. This is our standard Phi battery here, the 3.8. It has this nice wall bracket, and SimpliPhi batteries can fit in the wall bracket as well. Down here is one of our smaller batteries. This the Phi batteries, either 12 or 24 volt. This one, which is a 1.4 kilowatt hour battery, can either do 12 or 24 volts. So if you have a smaller system, 12 volt only, this is what you're going to want to be looking at. These don't have that digital, only analog. So we're really going to want to see you do a proper programming of that piece of equipment. The beauty of these is that you can scale these up to as many batteries as you want. I've seen systems up to 300 batteries. So what you have is no limitations on the communications. We're going to look at here in a second, but the SimpliPhi batteries are limited to, I believe, 40 batteries, because of the communications runs start to get too long. the Phi batteries, there's no comms cables to worry about. So you're able to just keep building them up in these building blocks and keep paralleling them up to meet the size system that you're going to need. The SimpliPhi battery, you know, it looks just like the standard Phi battery, except that it has these communication ports up here. These two ports on the left go between the batteries, and this port on the right here is what makes the home run. Of course, you have to use terminator plugs at either end of the systems, and we include those with all the batteries. Another thing to note is that the SimpliPhi batteries have a slightly higher max discharge rate at 100 amps at 10 minutes. So this is a 100 amp built-in breaker here, whereas the standard Phi batteries have an 80 amp breaker, so they can do 80 amps at 10 minutes. And this breaker is a great feature because essentially you can turn the battery off, and it helps with troubleshooting if we need to start isolating batteries to take readings. It also helps with install because I can turn this battery off, and knowing that I'm not going to have a risk of shorting these terminals out. Of course, I still want to be using insulated tools to be connecting all this stuff up, but it's a great installation feature. With the digital battery management system, with compatible equipment like Solar currently, like SMA Sunny Island, like our new inverter, we're working on others. We're working to incorporate Schneider XW Pro. I see somebody had asked that. We're not there yet, but always keep the keep your eyes on the horizon for this. With the standard Phi batteries, I always want to see that C/2 rating, where it's hard to tell an inverter to limit its power output to AC loads. But if you have a piece of equipment that we know is able to communicate, I'm going to let you go ahead and, instead of having that 8,000 watt radiant and needing 16 kilowatt hours of batteries, say with the Solar, you can go ahead and maybe have one battery on a Solar 8K or even a 12K, or two batteries on a Solar, because I know that the SimpliPhi batteries are going to communicate and tell the Solar, look, there's only one of us, there's only two of us here. Don't discharge or charge faster than we're capable of handling. And that allows you to approach a homeowner and do maybe a smaller battery bank than you initially had planned on, get the homeowner up and running with some critical loads panels, and then always let them know we can come back and expand your battery bank in the future. That's not common in our industry, that we allow people to come and expand to battery banks. Usually you don't want to go any longer than 2 or 3 years before you add one of our batteries to an existing battery bank, but it allows you to get in the door. We're limited, as I mentioned before, to 40 batteries because of the communication runs, but still 40 times 3.8 kilowatt hours is still a sizable system. So this is our little teaser slide. And we have upcoming trainings on our new totally vertically integrated energy storage system. So before, you'd get somebody else's inverter, somebody else's charge controller, somebody else's battery monitoring system, somebody else's AGS system. Now it's one inverter, one battery, one app, which means it's one warranty from one company, means one warranty, one tech support call, one system that's able to communicate with each other. With this new energy track, which is the battery management system's essentially digital interface with not only the battery management system, also the inverter. We can push over the air firmware updates. We can access this and do troubleshooting. So I'm really excited to announce this. We're just coming out with this. I don't even believe we started shipping these yet. We're going to start shipping them here really soon. Ask your distributor, ask your sales reps if you're interested more about this. But the battery, this battery here, has the digital battery management system built into it. It's able to communicate with still a Solar or a Sunny Island, and this inverter can work with other batteries as well. although we like to see you use the vertically integrated structure because that's what we really put a lot of work and design into. I promised you to show you what a high voltage stack controller looked like, and here it is. These are the batteries here at the bottom of the rack. Up here at the top is the battery management system that protects and controls the entire stack. So we're talking high voltage, right? 200 to 1,180 volts nominal DC. It provides that stack controller is able to and is rated for that higher voltage. Now, I'm not an expert on high voltage systems. It's usually in microgrids. We have containerized solutions. So if you're somebody that's interested in one of these larger solutions, reach out to me. I'll connect you up with one of our sales application engineers who can run you through all the details. They're more custom designed from what I understand. But I just wanted to explain, these are our 3 battery management system: the analog battery management system found in the standard Phi batteries, the digital battery management system found in our SimpliPhi batteries, and also that new 4.98 kilowatt hour SimpliPhi battery, and the stack controller, which is found in our high voltage products. And the concept here is that it's an external battery management system, not internal like the Phi and the SimpliPhi batteries. So kind of the takeaway here is that a digital battery management system isn't necessarily any better than a battery that has an analog battery management system. Imagine you come out to a home that has some old, Xantrex pieces of equipment. As long as those older pieces of equipment can meet the set points that we want to see, there's no reason you need a digital battery management system, because there's no way that old Xantrex is even going to be able to talk to that piece of equipment. So you got a lead acid battery replacement customer, sell them the standard Phi batteries. You can get that system programmed properly. Let's size the system properly so that we're always meeting that C/2 continuous charge and discharge rate. If you go by the SimpliPhi batteries, I know for us, our SimpliPhi digital battery management systems are more expensive than the standard Phi battery, but they're still really the same battery. They still have the same chemistry, the same form factor, that same cell construction, the way we assembled the battery. There's no reason to use a digital battery management system when you don't have, when you can't. It's just more expensive. You're paying for something you don't need. So it's not like that one's better than the other. It's just they have different applications. Sure, if you're coming out to a newer system, a grid-tied system, maybe a system that's going to be looking to start working on virtual power plants where on the horizon, your local utility is going to want to be able to take control of your energy storage system and discharge it when the utility wants it to discharge. Of course, they financially compensate you for this. Let's start thinking about digital battery management systems, grid-tied people who want an app. Those are the people that that are going to need a digital battery management system, because they're going to get that higher level monitoring data, because the battery's telling the piece of equipment what its state of charge is, what's happening to the voltage, to the current flow. If you're doing advanced grid interaction, that's that virtual power plant. You're going to need some digital battery management systems. Commercial and industrial, I'm not the expert in that, but you're going to want to have better controls around that. So you got some old off-grid people. Let's sell them the standard Phi batteries. There's no reason to replace that older pieces of equipment as long as it can meet the custom set points that we want to see, like a 48-volt low voltage battery cutout, like us to be able to turn off equalize, because we don't want to equalize these batteries. Those little set points, go ahead and sell them the standard Phi. Thanks everyone for being here. We're looks like we're kind of wrapping up a little bit faster. We're moving along a little bit faster. The last thing I wanted to talk about with everyone today is our Elite IQ program. If you are installing our batteries already or looking to install our batteries, please join our IQ program. I want to be clear that being part of the IQ program is not a requirement to install our batteries. It's simply a way for us to help boost your business and you help boost ours, right? We'll put you on your company on the maps so that if somebody comes to the SimpliPhi website maps, online locator maps, and they're in your area, we will send the business to you. Our sales application engineers will look it up the same way, send them to you. So we'll put you on a map, include you in our IQ newsletter. We can get you money. Money always resonates with a lot of people. We can get a photo contest, $250. And we've been offering a $25 cash back per battery. That's not a credit, that's not a rebate, that's $25 cash back for every battery you install. And we handle that through the warranty process. We love photos, right? I love photos. So what again, I mentioned $250 for your photo contest. I love photos of equipment, but what I like most is photos of people in front of the equipment, whether it's you, the installer, whether it's the homeowner. It really tells more of a story when you see pictures of people. We roll the entries over. So if you don't win one month, we can always roll it over to the next month. Here's the link. Everyone's going to get a copy of this presentation emailed to them. And if you aren't able to make it work, contact me directly and I can help walk you through it. So if anyone's looking for the NABCEP credits, that's my email right there, moyer.daniel@basco.com, briggsandstrattoncompany.com. Email me. I will get you your certificate. Please include your full first and last name because it's really important that I spell your name correctly on the certificate. Otherwise, NABCEP's not going to like it. If you have a question, now is the time to put it in the Q&A chat. We're going to jump into questions here and walk through some of this. I like to thank everybody for joining us. I'm going to plug some of our other trainings. We have other trainings upcoming on extreme weather. We have other trainings on charge and discharge, AC, DC coupling, kind of the basic battery chemistry 101. So take a look at our pre-recorded sessions. Take a look at our upcoming training calendar as well. And I believe we might have Nathan with us, who's one of my colleagues. So maybe he can help me run through some of these questions. Michael, I see you're asking for a certificate. Please email me there. Glenn asks, yeah, Glenn, if you're interested in your project in Haiti, go ahead and email me, moyer.daniel@basco.com. I will connect you up with one of our sales application engineers. Or if you're already working with someone, let's make sure we get you the support you need. Glenn, you had asked, does SimpliPhi communicate with the Schneider XW Pro Plus? Not at this time. I already answered your question live, but keep in mind, everyone, we're trying to add communication capabilities to equipment as it comes along. We want to be sure that we get it right, and we're not just saying it works with everybody's. We want to make sure that we're able to keep whether it's CAN bus, Modbus, I'm not the expert in it, just to make sure that it's done right and we just don't rush to market with it. Pedro asks, do you have a 3-phase inverter from Briggs? Not yet. We wanted to get it to market with just to get it out, get it going. So there's a lot of future plans for this product that I can only dream of that I would love to see that are coming out. It out of the gate, we're offering a lot of opportunities like built-in MPPT charge controllers, a built-in AP systems, rapid transmitter built into the system, rapid shutdown capabilities, 2-button, 2-wire gen start capabilities, an extra AC port, so you can AC couple a generator or AC couple solar onto it. A lot of exciting things, that energy track system. So keep up with the news, and you'll hear. We can't do more than 40 batteries. How do your computers simplify BMS? I'm not sure.
I think he's asking if we
Nathan.
offer bigger batteries there, Daniel. I mean, we have the 4.9 kilowatt hour battery that Daniel mentioned earlier.
Yeah, and that brings up, thank you, Nathan. That brings up a good point. You know, we build our batteries in 5 kilowatt hour increments, because we've always had the approach at SimpliPhi of being scalable, of having building blocks that allow us to build the system out that you need, right? So rather than going out and buying some lithium-ion cobalt-based chemistry battery that is in increments of 13.5 kilowatt hours, and you need 15, well, now you have to buy 2 batteries and you're at 26 kilowatt hours. With our smaller incremental building blocks, you're able to buy them and build them up as you need them. And the same holds to that inverter, right? It's a 6K inverter. You can stack those inverters for the same price as you could buy one inverter from one of our competition. So the ability to scale it up is important. It's always been something we focused on. Let's sell you not something bigger than you need to get your homeowner started, and let's get it going. Thanks, Nathan, for helping in. And Nathan, help me if any of these, if you see some of them, just chime in. Samuel, you're asking, you're interested in the utility scale as well as low voltage. Please email me. I'll connect you up with someone, sales application engineers, who can help you out. Glenn asks, what's the weight of the high voltage stack system? I don't know. It looks pretty heavy to me. And I imagine you wouldn't move it at once, right? You would put a rack in and then you would slide the modules in. I assume the weight would change as how many modules you have in there. Email us and oh, sorry, Glenn, I see I'm getting to the questions. It seems like you're talking to somebody already here. Garrett, he's a great guy. Yeah, Todd is asking, can the Phi BMS be upgraded? Now, the standard Phi battery management system is that internal analog one. Answer is no. You don't really want to be opening up the batteries and changing anything in there. It voids the warranty, I believe, if you open it up. It's a solid battery management system from the start. If you're looking to upgrade something and you want more, you want to know more, think about adding a Victron battery management system to the system, right? So you got your standard Phi batteries. Sounds like you already have a system. Maybe the homeowner is not getting the most accurate readings because it's trying to use voltage readings. Well, a Victron, what is it? BMV 712 has a shunt. It can measure amps in, amps out. It has Bluetooth. So think of other accessories that you can add to a system to add that whatever upgraded features you're looking for. Gail asks, what are your plans for recycling and repurposing avenues already set up? That's a great question. I feel like the whole industry is trying to grapple with that, with everything from how do we recycle solar modules to cobalt batteries have that cobalt in them, which is, I believe, much more difficult to recycle properly, whereas lithium iron phosphate batteries, of course, you just don't want to go take them to your local dump, but they are less toxic when it comes to recycling them. I'm not the expert on that, and I believe there's whole companies that are being set up predicated on just these concerns that you're asking. How can you, Jose is asking, how can you detect when the battery management system is not working correctly? Well, most likely it's going to open up. You're going to take your multimeter to the battery, and instead of seeing 48 volts or 50 volts or whatever you're expecting to see, you're going to see like 1 volt or 10 volts or something like that. And It actually, in a way, that means that the battery management system was working correctly because it opened itself up and it's protecting the internals. If after we attempt to get the battery management system to come alive using inputs that are now nominal to what the battery wants to see, and you're still not seeing the battery management system come alive, then yes, we can really, the short answer is you'd have to send it back to our factory, and we could have one of our engineers test it. And that's something we could do. We have RMA processes. Tech support at SimpliPhiPower.com is where you're going to want to email. There's ways to bring these batteries alive in the field. That's going to be the best way to do that. Yeah. Pedro saying, yeah. So again, we got a lot to. I'm not Pedro. I'm not sure about that monitoring. I do know this, that when you have a lot of people have monitoring, everybody wants an app now. Everybody wants to be able to monitor their system. And when you have something that's fully vertically integrated, something that's able to talk to each other, you're getting that app that not only allows you to see what's happening, but make changes. And everyone as the installer can also come in and change parameters as you see fit. So imagine you're out to a site, you commission it, and you set the low battery cutoff to always maintain 80% or like a 20% stated charge, right? You're discharging down to 80% DOD. Homeowner starts to say, well, it's not enough power. And they start complaining, well, you don't have to do another truck roll and go out there to some piece of equipment and stand out there outside programming buttons. You can get into your fleet management system, maybe adjust it down to a 90% depth of discharge, give them that, let them use a little bit more of their battery and not have to drive out there. So it's hard for me to compare monitoring to another company that I'm not familiar with, but in any monitoring system, these are the things you're going to want to look for is, fleet management, something that's consistent across all of the products, something that just, looks nice, works nice, something that is going to allow you to commission a system easily. I've had to stand out in front of a SunPower, I shouldn't say names, but I've had to stand out in front of a system with my phone, and the firmware is trying to download from the internet and it's uploading, and I'm standing out in the rain all day. The firmware on our app is preloaded onto your phone. So when you show up to commission one of these new Briggs systems, it's an easy 5-step process. I'm crossing my fingers when I say that, but it's not complicated. And a monitoring system is more than just that. It's helping you with tech support, warranties, commissioning, adjusting. So if that's it, I don't see any more questions. Thank you everyone for joining. Thank you, Nathan, for being here with me.
Happy to help.
Yeah. And
thank you for attending, everyone.
Yeah, and we'll see you guys next time.